Good afternoon, everybody. Thank you for joining us in person and virtually. I see many people connected online, so that's great. And I'm Paolo Ciuccarelli. I'm the founding director of the Center for Design that is hosting this conversation. And for those who don't know what the Center for Design is the kind of research platform for our College of Engineering and Design to foster the design research and research led in a way by design, facilitated by design. And we are using these conversation series as a way to open up new directions or to really address questions for which we don't have answers yet. So, and we always try to invite people from different fields and representing different perspectives on the topics. And so that's why we are here together to discuss yet another very, very open question. And we're still in a kind of a party festive mood because it's our 50th year for those conversations. So they are, resisting fine. And I think that's good. It means that there is an interest in having those open debates around some very challenging topics. And today, we are just adding to what we have already discussed. This is just to give you a flavor of what we have been through in the past years, every possible corner, I would say, of the design research has been explored. And what I'm realizing now, and after these years, that is AI is indeed emerging as one of the topics, and usually it attracts a good audience, and we have always very good conversations. We actually started to discuss AI as part of the Center for Design conversation in 2023. And at that time was more about design in general and how design is changing because of design. And we had people from other universities and from design agencies discussing about that. And after that, we went on and we moved a little bit into the field that we will discuss today, that is data visualization. And we kind of divided in a way that this relationship in two chapters or two different moments. So we started from, what is that data visualization can do for AI, and that's what we discussed in the last series, in the spring series. And we had, again, people from other research institutions, and very nice here in person this time. So thank you for joining for this second round of discussion that it will address the other side of the relationship. So what AI can do, if there is anything that AI can do for data visualization, that's what we will be discussing today. Generative AI, especially, what is the role of that? Is this really something that is changing in a good way the way we work as data visualization researchers and professionals? And I'm just opening up the way for Enrico Bertini to introduce the panelists and to then address some of the questions that we have. So without further ado, I would leave the stage to Enrico. Just what I want to say is that yes, we're discussing AI more and more, but we don't take it for granted. We know that we understand it's changing. We, as I say, we do research, we do design in general, but it's something that we want to question deeply and before accepting, So, and this conversation, I think, is part of this idea and this approach that is very open on one side, but also very, very cautious on the other, in really taking AI for granted. So, without further ado, Enrico, the floor is yours.
Okay, thanks, Paolo. I just want to start by thanking you for pushing us to organize these events. I think it's crucial for us to talk about what's going on. It's like too big to ignore. I think that's the way I feel, and especially in my own area, that is data visualization. I've been resisting for a while, and it's like, I don't know. I think I have to figure out what is our role here. And as you already mentioned, we already organized one panel. And in organizing the second panel, we wanted to do something even more specific. And we were like, okay, how about looking into generative AI in particular, rather than making it so broad, and also asking us more specific questions. What can Gen AI really do for database, and it really is there to say, maybe questioning what it can or can't do. And yeah, and I'm really excited to have amazing panelists. So we have Vidya Setlur here in person. Thanks for coming in person and coming all the way. That's really appreciated. It really makes a big difference to have people in person. And Vidya is the senior director at Tableau Research. And she's been working on systems that mix natural language processing and visualization since a very long time. I think I can say that you are one of the pioneers of these in these areas. Well, it's true. You started back very long time ago with this idea of how can we use natural language processing in visualization, and as you can imagine now, it's really, really, really relevant. And then we have Victor Dibia. Thanks, Victor, for joining us. Victor is Principal Research Software Engineer at the Human AI Experiences team at Microsoft Research. And I got to know Victor through, especially through one of his work. He published a paper called Lydia, a tool for automatic generation of grammar-agnostic visualizations and infographics using large language models. I think that's another one of those cases where somebody did something really early on before anybody else figured it out. And I'm really curious to hear Victor's perspective. And then we have Pau Garcia. Pau is the founder of Domestic Data Streamers. If you haven't heard of Domestic Data Streamers, please Google it and check their amazing work. It's really hard to describe in words. Really do that. Take a couple of seconds to Google it, and you'll realize in a moment what kind of amazing studio it is. And I just took a couple of quotes from the website. So their byline is "fighting indifference towards data," which I find brilliant. And somewhere they say in their description, Domestic Data Streamers was founded with a simple idea that the world couldn't be understood without numbers, but it wouldn't be understood with numbers alone. I think it's great. So enough with introductions. We will have a few introductory presentations from our panelists. Then we will go through a few questions, and then we will open it up to the floor later on, both the floor, physical floor here, and then people online. So be ready to ask your questions. I think online they can start asking questions during from the get-go, right, Paolo?
Yeah, of course.
Okay, sure. Perfect. I'll let Vidya start.
Okay. I'm gonna change the view. Oh, there you go. All right. Well, thanks for having me. I'm super excited to be here on campus. I haven't actually come to Northeastern campus before, but I've been a Boston native. Just a little background, and I was going to show some content just as a provocation for you all to think about. You know, as Enrico mentioned, I manage this wonderful group of people at Tableau Research, and we are an industrial research group where we work on a range of problems in the space of helping people see and understand their data. We've been doing a lot of work in the space of semantics, natural language processing, multimodal interaction, as you see here, and figuring out how AI can be used as a thoughtful enabler to help us meet that mission. So it's a very, thoughtful way of not just using AI for the sake of AI, but really trying to figure out where it can enable and solve problems. And when people think about AI, particularly Gen AI, I think the tendency, the tendency is for people to think that AI is only used for generating copious amounts of text. But truly, there's many places within the visual analytics pipeline that AI can be helpful for. It can be used for natural language interaction. understanding and even enriching semantics and data, and being able to understand user intent, especially when the intent is underspecified or ambiguous. And more recently, I think GenAI has really opened the space for thinking about text as a first-class citizen, like any other chart type, and how text can be used as a visual communication medium for people to reason with their data. And so, you've probably seen this timeline of how these models have evolved, and every month there's a new improved model that comes out in the space of large language models. But there's often this dichotomy that we see, right? On one hand, we see AI being able to solve a lot of interesting problems that can help mankind, like new antibiotics for drug-resistant bacteria. But at the same time, there is also the sentiment that AI is going to pose a risk. I mean, is it going to eliminate people's jobs? Is it going to make humans redundant? So there is this interesting dichotomy and tension with this technology. But what I would say is, starting from the roots, the whole process of visual analysis is messy. Before you see a beautiful chart or a beautiful blog describing data, there's a lot that goes on under the hood. And most people, when you ask them in a room, how many people are excited about cleaning their data on a Friday evening? No hands up, right? So how do we really fundamentally solve this problem, right? And how do we actually support the cycle of analysis using AI as an enabler? This is my last slide to kind of get all of your thoughts going. I think there is a spectrum between human and AI technology, where there are kind of three main properties. Automation. What are some tasks in the visual analytics pipeline that can be completely automated? And we've seen this already, especially with coming up with joins, coming up with data cleaning. And where are there places where AI and humans need to cooperate? And that, to me, is that augmentation piece. But I think more interestingly, rather than thinking of AI replacing humans, I think there is a really rich, fertile space for human agency. By alleviating all the time that people spend in dealing with messy data, unclean data, and figuring out how to communicate with data, if we can have AI to automate and augment some pieces of that, with that extra time, what sort of human agency can we empower and enable? So I'm going to leave with that thought, and I'll let the other panelists weigh in.
Thank you.
Okay, thank you. Very good. Victor, you want to go next?
Sure. Let me try to do a screen share. Just let me know if you can see the screen share.
Yes.
Yeah. Okay, great. Well, first of all, thank you, Enrico and Paolo, for the opportunity to be a part of this really cool group. My name is Victor Dibia. I'm a research software engineer at the Hacks group at Microsoft Research. And the charter for the group is that we care about scenarios where a human works in tandem with an AI model to solve a problem. One of the first things we helped with was GitHub Copilot, which is one of the first examples of a large generative model at the scale that we know today, working in real time with developers as a plugin in their IDE to sort of solve problems. And so spend a lot of time thinking about the human factors of that, the augmentation aspect of it, the right user experience and things like that. And before that, I was a ML engineer at Cloudera. I helped build out some of the product there. And then before that, I was at IBM Research for a few years. And so some of the ideas I'll talk about today has benefited from conversations with my teammates on the Hacks team, Salima Mershi, Adam Foni, Gagan Bansal, and also close collaborators from the Vidya team at Microsoft Research, so Steve Drucker, Dan Marshall, Cheng Wang, and Jivana Inala. And so Over the last few years, a lot of my work has sort of looked at applications of machine learning models, deep learning models to data visualization tasks. And as Enrico mentioned, LiDAR was not actually my first touch with this stuff. About 6 years ago, which is generations in AI, in the AI world, while I was at IBM Research and Time in 2018, a couple of colleagues, mostly I think I, myself, and Chagatai Demirab, we had a few conversations, and the question was, can we start to leverage some of the very high quality modeling capabilities we're seeing in deep neural networks and enable the complete generation of visualizations just from data? Again, there's a lot of, the focus was more on automation here as opposed to low-level augmentation. But our idea back then was that could we take a sequence-to-sequence model that has shown a lot of promise in language translation. So you have pairs of data pairs, English, French, and you get this model, you show it a lot of it, and it learns a mapping function from English to French. And so our idea was that what if we represented data as just text and visualization as text, Vega Light? Can we construct samples, do some really good pre-processing, post-processing, and then get these models to learn this mapping where like we give it like some samples from data at test time, and it gives us a set of visualization recommendations that kind of are grounded and make sense for that data set. And we showed a lot of good results back then, but then there were a bunch of issues, a bunch of challenges, like this thing wasn't very controllable. It might hallucinate fields. There was no way to specify the type of visualization and coding strategy that the user wanted to sort of explore. And very early on, I think Vidya's group has started to look at like, conditioning, visualization, generation, and natural language intent. And so fast forward down to some time in 2020, OpenAI had just released models that did really, really well in generating code. And so I sort of asked the question, can we revisit a project like Data to Vs and make it better? And that's sort of how LiDAR was born. And so LiDAR explores this 4-stage pipeline where we say if we wanted to really create a tool that helped users or assisted or enabled users in creating visualization, we'll have 4 modules. The first is a data summarization module. And the goal here is just to come up with a representation of the data that's rich but dense and can be the foundation for every other thing you ask the model to do related to that data set. And so once you have that representation, the next two is automatic hypothesis generation. So it's like we tell the model like, here's everything we know about this data. Very similar to how we might work with a human expert. Can you come up with a bunch of questions? And for each of these questions, what are representative visualizations? And then once we have those things, we can then again use an LLM, say, we have this data, we have this hypothesis, we have this visualization we're interested in. Can we generate code that like addresses this intent? And then we can compile the code that gets generated. We can do some post-processing, some filtering, some improvements, explore multiple approaches, and then give the user a final visualization. And so that's all about LiDAR. I think more recently, there's been, in my line of work, I'm very involved in multi-agent systems, and I might come back to this later, but I feel like the future might involve some sort of system that have generalist agents that can collaborate, interact to sort of help users across the entire stack of visualization tasks. And for my last slide, I have a set of key takeaways, and I can get back to these at some point. The first is that GenAI enables new data visualization tasks, and with LiDAR, that becomes pretty clear. Data enrichment, data annotation is now possible. Things like automatic hypothesis generation, generation of visualization, natural language-based visualization editing, self-evaluation of visualization quality. Of course, there are caveats there. But there again, there are also reliability and trust challenges that we need to deal with. In my experience and also from consulting, working with product teams here at Microsoft, reliability is always a huge issue. And one of the ways that we can address that, or two main strategies that we can address that with, is to focus on rich metadata and grounding for the summarization module or whatever it is that like how that determines how the data set is represented to a model. And something else called constraint generation. And so I've seen a lot of situations where a lot of people rush to give the LLM open-ended, unconstrained free room to address tasks. And so typically that's a mistake because it just massively increases the surface of error for what surface of errors that the LLM can explore. Instead, a common pattern is to identify or enumerate a constrained set of visualization directions. In LiDAR, we explore the idea of code scaffolds, where we say if you're going to generate a plot in Seaborn, here's a code representation of a Seaborn chart. Don't generate the whole thing, just fill in specific aspects of this template or this scaffold and do it in conjunction with all the context that you've been given. We're seeing that with other products where, products have like a set of visualization types that they support templates, and rather than just asking the LLM to generate a lot of visualizations, we constrain that there. And then two more things, benchmarks are critical. Multi-agent systems are probably the future. And then there are a set of patterns that sort of emerging, constraint generation, hybrid interfaces, which means text is probably not the right thing. We need a combination of direct manipulation and text-based natural language editing, sandboxing for code generation, and then verification tooling to sort of build trust. And so I'll stop here and hand it over back to Enrico.
Great, thanks, Victor. I think we can move on to Pau.
Sure. Hello, everyone. Let me share my screen. Can you see it well?
Yep.
Yes.
Great.
Here we go. Okay, well, first of all, thanks, Paolo and Enrico, for inviting me here. I'm, as you said, one of the founders of Domestic Data Streamers. We do like all kinds of things, from like data visualizations to what we call info experiences, that is bringing more data visualization into the physical realm, right? And that have taken us to very weird and interesting spaces at the same time, trying to understand that data visualization needs a specific context to be understood most of the time when you release it from the digital screens. In terms of AI, what our experience in the studio, we have produced most of the tools that we are working and we are using right now. And we started using them in 2021 when we were doing one of the first systems on data capture from different video streaming platforms. In this case, and the big learning for us was that somehow GenAI and data visualization were part of the same ecosystem, right? In this case, we were actually somehow taking the streaming cameras from different Congress and parliaments, and we will actually train this algorithm that will track whenever someone was falling asleep in the parliament. So it was a good way to actually make a heat map, a visualization of the sleepiness in different places, right? This has been done like with the idea to actually publish it on Twitter all the time, but it's a bit complicated. But through doing this first early experiment, we somehow saw the potential of crossing these two things. For once, artificial intelligence and the tools of artificial intelligence, and on the other hand, like the way we can visualize the effects of it, the captures of it, and the talents of it. But I think one of the most important things that I wanted to share with you today was the idea of divergence and convergence. That somehow is part of any creative endeavor. Like you have both things, right? In divergence, you're opening yourself up to new ideas and possibilities. You're gathering, I don't know, it's inspiring material, scrabbling furiously on napkins, or mainly making your mind roam free. And in convergence, you are narrowing things down. You are tweaking, refining, you're choosing exactly the right word, or getting the saturation to that chart exactly to the point. You're making sure everything is pixel perfect, right? Divergence and convergence are kind of the breathing act of the creative process. you are constantly breathing in new things and breathing out refinements. Breathe in, breathe out. And I think, at least for me, most of the design tools for data visualization focus on conversions. Illustrator, Figma, like Google Docs, Excel, all these tools, these are tools that are built for refining a rough draft into somehow a final output. So they have sliders, filters, and a lot of formatting tools. And their interfaces are built for precision, right? Like for this pixel perfection. And it's not so common that we see these tools create something unexpected, right? And NLPs and in general Gen AI feel a bit different. I have, since the first moment I started to use Gen AI, I started to see very divergent kind of outputs, things that I never thought of, but somehow were really interesting. So I think these tools are kind of allow us to breathe in kind of a vast array of possibilities, like enhancing, I think, a bit of the creative process when doing research. And this has a lot to do with the idea of designing tools based on command or intent, right? So for example, when we think on command, it's much more focused on conversions, like the traditional data visualization tools have been rooted in like this command-driven paradigm, like Tableau, like Excel, any programming libraries, they somehow, you have to set the exact set of instructions to produce like this visual representation of data, selecting chart types, defining axes, and so on. I think now with the switch of tools, we are going into this space of intent, right? Which is somehow building, okay, I want to go there, but I still don't know which is the best way to get to that direction, right? And this opens and translates the discussion. Instead of focusing on what am I doing, it's focused more on why I am doing what I'm doing, right? So at least for me, it's kind of a relief because it feels that I'm spending more time in that space. And to give an example of this is a small experiment we did, kind of creating a RAG system and a knowledge graph based on the Holy Scriptures. And we like kind of hooked like and take like from the Gospels to the Wisdom of Solomon to like all the different books of the Bible, and we created like this huge RAG system with all like these different kind of artifacts that we will be able in a local computer to ask questions. We will create like these mermaid systems that will output data visualization, like different graphs. So for example, if I say extract the most important ideas behind the Bible, you will get something like this, right? And you can say, hey, extend it with the most important people and places involved. And then you somehow start to explore in a different way the information, all these data sets. And I think this is where I think there is another convergence between data visualization and AI. Like there are a lot of possibilities and potential ways to make visible information that right now is kind of difficult to see and explore, or it takes a lot of time, right? So if you ask, find contradictions within those texts, then you start to see things like, for example, the Genesis and Exodus. The Genesis say, Jacob saw God face to face, and the Exodus say, no one can see God and live, right? Like, so you start to use this system as a way to somehow find other potential informations that otherwise will be very difficult to get. Like, for example, this one was very interesting experiment. Extract the data in a CSV about the amount of times God killed someone. This is like a very long spreadsheet. Like really, it's a gigantic spreadsheet of the amount of people that were killed, and then categorize it and visualize it, which was kind of beautiful because in this case, even the the LLM was kind of funny. He said, well, most of the times it's because natural disasters or overreactions of God, right? So for me, it was even kind of demonstrating a bit of a fun perspective, but also gives you a perspective on how we can interact conversationally with certain information. Find me another data set to give dimension to this tragedy, like this, what we asked. And this is the data set that came from it. God's body count, 5 million people, and Satan body count 10 kilos, right? So it somehow have this perspective and can help figure out new ways to look at the data, right? Comparing it, expanding it, and looking for like potential correlations and relations between data sets that are not so obvious. And for me, that was kind of liberating. Even at the end, as you can see here, God's body count, there was an asterisk, and it said, without including the flood, which is estimated at the time to kill 20 million people. And it was a huge environmental disaster. So things that happen, this is something to think a lot about. Command and intent, conversions and diversions, I think like this is one of the biggest parts of what I'm interested on the focus of artificial intelligence. And that's a bit about it.
Thank you, Paul. Thank you all. Panels, this first round of thoughts.
Well, a very good start. So I thought I would start very classic, and I'll ask each of you. I think Pau already kind of covered it a little bit. What are the most exciting opportunities for you with Gen AI applied to data visualization? I just want to say this could either come from your work or even from your personal use of Gen AI for visualization.
So this is me?
Yeah, you maybe
Okay.
you.
So for me, I think one thing that we have always explored in domestic data streamers, it has been the idea of using data and statistics and like all this space, this landscape of data as a language, and try to find the grammar of it, right? And somehow NLPs and the way they work kind of make sense within this framework. So for us, it has been more about, okay, in which ways we can use all these mechanisms and platforms to actually further develop visualization. One of the early experiments we did also was to fine-tune GPT-2 with hundreds of conversations around certain type of violence, right? And what was interesting was that when it started to generate new conversations, we could see patterns, we could see certain nuances in the conversation that before were impossible to see from the raw data that we were inspecting. So I think, for example, the biases, the bias that is entangled within the way we train these algorithms can be another really interesting way to visualize certain behaviors from the community, from the society. And I think a good example of this was when people were asking for a photo of a CEO on OpenAI DALL-E 2, and you could see which were the kind of CEOs that were taking out. This for me was kind of a great data visualization of how the Western world looks at CEOs, right? So I think this is a gigantic tool of visualization by itself. These generative systems are biased towards certain ways to visualize the reality.
Wants to go next, Vidya?
Yeah, are you sure, Victor? Okay, I can go. I think there are a few things where I've been personally excited about AI. One thing is, at least my own personal research in my group, we've always striven for designing and building tools that make data analysis and exploration more accessible to the wider audience. So not being, formally trained in analytics, but having anyone who's intrinsically curious about information and data and they want to act upon it, making those tools accessible. And I think AI in some ways has kind of reduced some of the friction in bridging the more complex analytical tasks with people who may not have some of the deeper analytical chops to do so. So that's one thing. The other piece I think is, AI can be a pretty good multiplier factor for helping humans combine ideas from different sources. So at Tableau, we have a huge customer community where people regularly design and create, I would say very thought-provoking charts and dashboards, and they post it on Tableau Public. And we're trying to find a way in which we could take inspiration from these people and their ideas and provide kind of design suggestions or scaffolding for someone who is starting in this space saying, you know what, this particular, community member designed this Sankey chart this way for this data. You might want to take inspiration from that, or here are some links. So it kind of brings and bridges human creativity with other members of the community in kind of interesting, accessible ways. And then the last piece I will say, I mean, there's plenty of pitfalls that we should discuss about AI, but I think the other positive place is, as I mentioned in my short presentation, trying to automate and make some of the high friction tasks in the visual analytics pipeline less tedious. So being able to join different data sets, being able to address the nulls or badly formatted strings into date formats, those things can be done quite easily and almost automatically using AI, which I think is pretty empowering. So I'll stop there and I'll let Victor weigh in.
Yeah. So I agree with everything everyone has said so far. One of the things that I am excited about personally is about teaching and writing and learning. And one of the things I think about frequently is how does the process of teaching, like data visualization literacy or data visualization skills, change? And are educators a little free? Do they have more latitude to focus on concepts and ideas and separate implementation and get an LM to do that? And so do you teach design principles of good visualizations? Do you focus on, let's say, strategies for debugging and evaluating visualization? Because that's going to be a really important key, because now an LM or a GenAI model can easily create a visualization, but then you need a bit of skill to ensure this thing is not lying with data, or it's not misleading with data, or it's not like creating visualizations that tell incorrect stories. And so maybe there's like an opportunity there to restructure and improve the teaching or learning process. And so that's one. Another interesting piece has to do with the whole question around reliability, which I'm sure we'll get to. But are there other ways that we can still use LLMs but still stay reliable? And one of the favorite projects, interesting things I've seen recently is the idea of contextual embedding models. So if a lot of you have worked with embedding models, the idea is that like you have text, you generate a bunch of embeddings, you might do some clustering on top of it, and then post hoc, you'll try to interpret those clusters, and then you have these nice visualizations. I think LLMs hold opportunity to improve that process, where like instead of having to manually label those clusters, you can create a really nice pipeline that can reliably use an LLM to do some clustering and then label each of the clusters in a way that's kind of reliable. Let me see if I can show. There's a quick demo I put together kind of recently. And so the idea is that typically you had like an embedding model, and at runtime you get embeddings out of this thing and you could never change it. But with contextual embeddings, you could actually give instructions and say things like, while you generate embeddings, let's say focus on, so given a company description, retrieve other companies that's semantically similar to these, and it'll give you a different embedding structure. Or you could tell things like classify the company description as artificial intelligence or not artificial intelligence, or something like classified company description as health or not the health domain. And interestingly, if you did this with the right underlying model, so the model used here is something called NV-embed, you get different embedding structures with a lot more accuracy that follow the instructions that you give. And then based on that, you can do a lot of high-level analysis. So this is like an example of generative AI models, in this case, shoehorned into the text embedding space, but with the potential to really improve or sort of like redefine this workflow. So this project is a bit nerdy, but I'll say this is one of these examples. And the graph you see here, let's just do a really cool comparison. So these are all like company titles. This is from the Y Combinator database. It's the description of each company. And if we use the base embedding and we just did like a simple labeling schema where we like said, does this thing mention health? You can see that like all the companies that mention health, they're in this little quadrant, but then they're not very nicely structured, like nice cluster structures. But then if you use this contextual embedding where you had this instruction where you told the LLM classify the company as health and not health, then you get this nice structure that, and then you can do all these other things on top of that. And even companies that like do not mention health, they are in this nice cluster, and you can reliably run clustering algorithms, set your number of clusters to 2, and you get very reliable results. So this is like an example of another area I'm quite excited about. Yeah.
Okay, thank you. I do intend to switch to the problems, but before, of course, but before that, I was really inspired by some of the things that you mentioned, because it almost looks like a little paradoxical that AI typically is to automate things, right? And here, when I look at some of the things you mentioned and the way we end up using AI in visualization, it seems to enhance the human side of things somehow, and also to enable more, I don't know, maybe more creativity or more interactivity. If you would have asked me like 5 years ago, I would be like, what? AI is doing that? Enabling that would be crazy. But we can clearly see that happening somehow, with limitations, of course. I was wondering if you have more thoughts about this aspect.
Creativity.
Yeah, somehow, yeah, making humans even more. Well, I think you said augmentation, right?
Yeah.
And human agency. I wouldn't expect AI systems to provide more human agency rather than less.
Right.
Maybe I have the wrong mental model, but
I
I mean,
think that is.
yeah,
Please.
go ahead. No,
No.
please go ahead. No,
Okay.
I just have a funny anecdote about just, using AI as a creative experiment. So last week, there were 2 conferences that happened in the data viz community, right? So there was the IEEE Viz, which was virtual, but there was also WIST, the user interface software technology, which was not virtual, and it was in Pittsburgh. And a few of us were on a thread where we were trying to use DALL-E to generate logos. And so one of them was very interesting. I'll try to pull it up in a second while the other panelists talk. But I basically put in a prompt saying, create a logo that explains the sentiment that this is virtual because of Hurricane Milton. And WIST is now in Pittsburgh, and a lot of this people are actually hanging out, in their own like satellite groups. And it came up with this kind of brilliant juxtaposition of the waves of the hurricane and the Pittsburgh building kind of coming together. And so to me, it's like, to your point, Enrico, I mean, I think with human creativity, we tend to feed off of other people's ideas when we come up with a creative artifact. And I think AI is really a good enabler to help with that. But I'll let the others chime in as well.
I think there is also a part of it that is about accessibility. I think one of the most amazing parts of these new tools is that they are easy to use. Which, if you think about it, only 3% of the people in the world now can code a line of code. And that means that this 3% is actually designing the digital world for the rest of the 97%, which means that we only have a 3% of the world being creative on that space, right? So I think just the fact that we can increase that 3% to a 15% or a 20% or even a 7, that's already the more than the double, right? So I think just the fact that this system that is using natural language can make more accessible these ways of thinking to more people, that will create by itself new kinds of creativity, new kinds of ways of looking at the data, right?
Yeah. Just to add to that, I think there are several user profiles, and so in my work with LiDAR, I've seen that like LiDAR, they're like novice visualization developers and they're experts. I'm sure this room is full of experts, but the impact of a tool like LiDAR and any other generative model for these novices is just outsized. It might look simple to the whole idea of coming up with good questions for data visualization. Might look very simple and trivial to most of us, but it's not very intuitive for a lot of people. They're like, we just don't know where to start. And even when they had like a good idea, okay, I want to know the relationship between, I don't know, miles per gallon and the size of a car, they're not really sure, like what is a bar chart or line chart and all this stuff. And having something that can like at least take a first step in that direction can be very, very valuable. And then also the cognitive burden of doing some things, doing some stuff from scratch as opposed to selecting from a list of things or modifying something that exists. I think it's just the burden is just very, very different. And so as opposed to creating a visualization from scratch, maybe it's an easier thing to say, how about I select one of 5 visualizations, or how about I select the visualization and then I say something like, okay, remove this part, remove that part. So it changes the process from just low-level creation to maybe curation and editing, which can really make the iteration loop a lot faster. And then on the surface, it looks like it sort of presents as just better creativity. So that's my thought there.
I have a question, if I may start opening up a little bit the conversation. So speaking about creativity, and it might seem like a silly question, but would generative AI be ever able to come up with a new visual model that is not like, the usual ones? That is it thinking about in terms of bar charts and pie charts, or is there anything that we can do for opening up a little space also in terms of the way we visually represent data? And because so far we spoke about a lot about what comes first and before then we get to the visual. But when it comes to the visual, is there any possibility to use it in a creative way that goes beyond what are the usual patterns that we use to visualize data?
I could share some of the experiments we have been doing during the last years. This is a series of experiments which are like on the internet. You can access to them, which are prompt books for data lovers, and somehow they explore the grammar of the way we visualize, somehow from semantics to image, right? And when we started these experiments, we started from a blue cube as a 3-dimensional object. And then we started using like the Bertini morphology and like these different ways that we already use to create data visualizations and integrating it and trying to see how these image generators will react to all of this. And I think for us, what was more interesting was when we started to integrate other perspectives, more focused on data physicalization, because of course we can generate any kind of image. We can now like generate things that are in the space of subjectivity also, but that can semantically be very well understood when we want to somehow express certain things, certain information that is encoded into images, which can be much richer than just visual, like standard representations of data. And these were some of the examples that we started to do, like trying to transform, for example, a word polluted into a whole space where you could make a visualization about pollution, right? And how like the construction of new semantics could actually build new ways of making visible information, like in this case, making a cartography of air pollution based on the health of the ecosystem that we had built up over this representation of a map, right? And all of this has been created like with data visualization, with generative AI. And of course, like this enters into the realm of, okay, which of these are scientific data visualizations, and how accurate are they? Are they just sending a message, or are they just like opening a debate or a conversation on that? But I think in this space there is a lot of discussion to have, because we are not anymore constrained to the basic limitations of the standards.
I think though, I mean, those are all really cool examples, and I can kind of definitely see infographics, like kind of the Nigel Holmes style, taking a whole different level. But I think there's also something cautionary, especially when we talk about statistically useful graphs, right? I mean, there's been a whole amount of research that has looked at the interplay between the key takeaway that an author expresses for a chart and making sure that the chart is also emphasizing the same information. And so there's so many nuances that go into play when you're creating statistically useful graphics. And I see this particularly important when you're working with enterprise customers, where every single chart or visualization generated in their dashboard is what is used for making these business-driven decisions. And so there needs to be a lot more rigor that goes into play in both generating and verifying those charts, right? And I think the question to bear is, is AI going to get to that spot? Probably, right? I mean, as someone commented in chat, AI takes inspiration from examples that are often human created, right? But I think right now, I have seen that bridging some of the academic rigor that we put into statistical usefulness of graphs with AI generation, either through prompt, guardrails or verification after, AI generates this chart, is still a very pertinent problem. Maybe in a couple years, we might meet again and that problem might go away. But right now it is still a problem. And that opens the whole box around hallucinations and errors and things like that.
Yeah, to me, I mean, not being an expert in AI, I'm not a designer or architect, so
yeah,
it's really strange to see how AI is actually enabling, as Paul showed us, kind of more human, creative way of visualizing data, that we can use for communication purposes, for example, but it's not able, as far as I know, to generate statistically, mathematical, relevant new charts, that people like Playfair or others were able to generate in the 19th century. So, and that's interesting, that is a pure mathematical technology, statistical technology that doesn't generate statistically relevant charts, but instead is able to generate like those infographics that seems much more human at heart. So I don't know, just very open reflection on this creativity that is offered.
Yeah. While listening to everyone, one of the things I was thinking about is, in some way we can think of visualizations as programs. So the space is constrained. Or in some way it is constrained. So one of the reasons why I think generative AI models are great at code is because programming languages are a fairly finite space. It's super structured, quite finite. And if you can model that distribution really well, then you have a really good shot at almost always generating like high quality code. If we think of data visualizations from that perspective, we have grammars across multiple types of grammars. And then we have models that can learn the distribution of these grammars really well. Then we have a good shot of generating a lot of high quality or mostly high quality visualization. Again, that's where the idea of constraint generation comes in, where like we figure out ways to get the model to just stay within the boundaries of some grammar. And if we do that well, then we have a good shot at solving the visualization problem. And so that's one thing that I thought would be useful to bring up here. The second thing is that like generative models learn the mean of the distribution. So like if you ask the generative model today to solve a task, it's more likely to use a bar chart, a pie chart, or whatever is most representative in the training data. It's less likely to explore some completely new type of custom charts that can be done with, let's say, a low-level grammar like D3 or all that. And maybe that's where the tail of creativity lies. But by default, the LLM typically wouldn't do that. And so maybe in the future, things like highly creative, data specific or task specific visualizations that really lie in the long tail, maybe how we get there is by custom prompting or custom like designs, or we explore multi-agent approach where we have like an external agent that is encoded to enforce this type of properties, and it's in a loop with a primary agent generating a visualization, and they sort of work together to explore the long tail of like what might be, say, non-traditional custom visualizations, but are also valid in some way. These are just generic thoughts, but I still agree a lot with Vidya that reliability continues to be key because you want to make good decisions from visualizations. And so maybe pixel domain, just getting things to generate images might not be the way, but instead going from code that's structured, testable, verifiable in some way, and going from that to, let's say, to more creative spaces might be the way we need to go.
Yeah, it's kind of interesting, Victor. I mean, I have found personally kind of going back to some of the old traditional NLP techniques and revisiting them. So this whole like bounded space where visualizations are a type of grammar, right? That describes the specification of the chart. That actually is an old NLP school trick, right? Like probabilistic grammars and statistical NLP would always do that. There was an intermediate specification that these grammars would, like these systems would spit out, and you would just validate the integrity of that specification to verify if it is kosher or not. And what we have found, Tableau, we've been following that trick, right? We get the BizQL specification from these large language models, and we know the semantics of it, and we verify it, and only when it's verified, we show it to the user. And those are just like old tricks that have existed back in the day, but we revisit them now in this new context. I also kind of wanted to circle back to that comment on multi-agent, which I think is really interesting. And I think what we haven't talked about is, in addition to large language models, which we found can be kind of incredibly powerful in their own ways, but also have their own pitfalls just around hallucinations and black boxes, because we don't know what they're trained on and what's the provenance of what they're actually doing behind the scenes. I think there is an interesting open area around exploring small language models that are trained for very bespoke tasks, closed domains, and using it in a multi-agentic framework where you can use large language models for certain tasks, and you can use these small language models for very bespoke, specialized things. And you have this whole hybrid approach. So I don't know. I mean, I don't want to put you on the spot, Victor, but do you have any thoughts on maybe I'm like doing inner cross questioning here, but I'm curious if you've explored that space. Oh,
Yeah.
you're muted.
Yeah, and I'll be very brief. I know we're kind of close to time.
Yeah.
We have explored, so the whole idea of a multi-agent framework is that like you build a set of agents and you give them roles and responsibilities, give them access to tools, and then at runtime you give the team of agents a task and they sort of collaborate to solve it. And so we've explored scenarios where there's a primary agent that's meant to generate charts. And then there's something called a critic that has some list of properties that this chart should satisfy. And essentially when the task comes in, let's say the generator or the coder takes the first shot, that code gets executed, the results are shown. And then the critic sort of reviews the state of affairs, comes up with some suggestions, and then the coder has to like rewrite the code, and then the code gets executed again. So the idea is this tight loop where they sort of interact until at some point there's some stopping condition that where, let's say, there's a bunch of rubrics, those rubrics are met, and then the task is done. I totally can see how some of those agents might be powered by SLMs. They all don't need to be powered by GPT-4 or Cloud, which is very expensive. And so that setup makes a lot of sense to me. I also see that we've also been thinking about the idea of like in the visualization process, there are a lot of things going on there. So there's like the data annotation piece. There's things around just code generation. There's things around like code evaluation. There's things around like natural language-based editing. And so each of these are tasks, and we can generate massive data sets for these things and get small models to sort of meet the same quality that we see with much larger models. And then that way we improve latency and costs for these sort of systems.
Pau, do you want to comment on that as well?
At least for the experience we have had, that was a way of decreasing the hallucination process, just making a lot of like fragmenting the responsibility of LLMs and then creating a lot of middle steps, right, with smaller models so we could double check with our own databases, right? So that was a way that was not eliminating hallucinations, but somehow it was like dramatically decreasing it. So I think it's a process. Still, there are parts of the language that we use that sometimes when someone say multi-agents, someone is saying something and I feel I'm thinking about another thing. So like I think a part of the problem with AI now is also about the semantics, how we use certain words for so many different things. And it's sometimes difficult even to know what you are talking about. And you have been for 20 minutes talking about something, but the other person was talking about something else. So from time to time, I feel a bit lost.
Okay, so I think I would like to open the floor to questions. So if you are online, please type your question in the chat. And I don't know, maybe there's somebody who wants to start here.
Hi, thank you so much. I'm really interested in the idea of accuracy, which you were kind of just touching on. I'm trying to think through, presumably we use these tools because they're better at this than humans are. So how do you go about, like when you create this kind of data model, how do you go about then comparing it and evaluating if it's producing better results than a human would produce with the same data set? And obviously, like a human will take much longer to, look through like 10,000 survey responses, for example, like open-end, pieces of language than this model, but still.
I can chime in here. I think that's a really interesting question, and there are a few things that I have found to be helpful. One of them is benchmarking is really key. At least for us and from my perspective, even if we can get these models to be at par with human performance, that's a win. If it can surprise us in some places, that's a bonus. So we have a very kind of bounded set of analytical intents that we often use for creating, for any of these natural language systems. And it's a combination of cross-validating. So we have a series of small language models in-house. We use Claude, we use GPT, different variants, and we benchmark them pretty heavily. So unless these models meet a certain criteria of quality, they are not shipped in our products. I mean, we have a very high bar. That being said, what we haven't touched upon is also designing user interfaces and tools that set the right expectations to a user consuming these. So we have a lot of disclaimers. One of the challenges we have is, these LLMs tend to be black boxes, right? They're not interfaces, but how do we actually explain to the user that this is GPT generated? We do stuff where we show kind of, okay, this is how we validated it, so people can actually look at what we've done under the hood. But it has also caused us to rethink how we even design these features within our products and, even our research prototypes to account for that uncertainty that we get with these models. But I'll let Pau or Victor chime in, please.
For me, the sentence you said at the beginning, I don't think they are better than humans in most of the tasks. In fact, they are worse. But I think they are faster, and they have some capacities that are very hard for humans. So, for example, something that we are using them a lot is we have a program which is called the Haters Army, and it's a software where we actually throw like ideas, integrate like data sets, insights, and so on. And there is this army of like different prompted agents with different like rack systems that their only goal is to criticize whatever we are trying to do, right? And this is something that for a human is very difficult. First, because we have like fragile egos, and it's very hard to go through this process with another human. But if it's a robot, you don't care, right? But other than this, I think what is interesting is that you can integrate certain bias that you yourself don't have, right? And having these different perspectives, I think that enhances and improves a lot the kind of insights and ideas that you can get from like any kind of process regarding data. So I think adversarial thinking will be something that these models are very good at, and integrating adversarial thinking processes within any kind of data design process is also something that has improved a lot, a big part of the work we do.
Yeah, I could chime in real fast. So in my line of work, it's understanding reliability, how well these things work has been very important. And there are like two ways in which some progress has been made here, or at least some ways I've explored this. The first is there are some parts of the pipeline that are objective, and you can extract some objective metrics there. And so let's say you got this model to write some code in a specific grammar. You can try to compile the grammar and see how often the grammar just compiles. And so if it's code, how often the code compiles without any syntax or logic errors. And you can add that to your benchmark stack. But that doesn't tell you about the quality of the visualization. It doesn't tell you if it matches the user intent. It doesn't tell you about the aesthetics, use of encodings, and all of that. And for that, common practice is self-evaluation. I think there are a bunch of papers that IEEE released this year that sort of dug a bit more into that concept. And so the idea is like we assume that a really strong LLM is an oracle that has learned a lot about like what visualization quality means. And there are also some papers recently that show that like LLMs to a good extent match some of the design principles or philosophies that humans express. I probably will try to find that paper and put it in chat. And so the assumption here is like a really strong or large LLM like GPT-4 has learned those things. And when a chart is represented in the right way to it, it can assess or evaluate a chart across multiple dimensions. And so one of the things that's done in LiDAR is there's a module called a self-evaluation module. And what happens is that because we represent visualization as code, we give the LLM that code and we tell it to evaluate the visualization across 6 dimensions. So the first is their logic bugs or like just syntax errors, that sort of thing there. Is the right data transformation applied to the data set before it's visualized? Does the visualization comply with the user's intent? Is the right chart type and encoding used? And we ask it to comment generally about like aesthetics. And it turns out that like a really large model like GPT-4 Claude, they have encoded a lot of visualization in some fuzzy way that I think more work needs to be done to measure how well they do that. But it turns out that like they can give really sensible or useful evaluations of these dimensions, and they're really, really good at doing this for smaller models. And then if you're so inclined, you could take this critique or this evaluation and just add that to your loop where you say, you know, here are the dimensions that are limited, rewrite or update the visualization to fix these dimensions. So these are like two practices that are emerging in terms of how we sort of evaluate these models. Of course, there are latency constraints here. And there's just more work to be done to build like an evaluation, a generic benchmarking pipeline that tells a bit more about this. And if there are PhD students here, I feel like this type of work where we have like systems that rigorously benchmark all types of models, large models, small models on multiple visualization tasks, I think that will continue to be very valuable to this community. Yeah.
Can you show what it says about aesthetics?
I don't have one right now.
Oh, okay. I was curious.
Yeah.
Judgment.
Let me try and pull it up while the next person speaks. Yeah.
Okay, I think we have another question. Mela?
Yeah, so I think you guys touched upon that already. Like visualization has a mechanistic part and a creative part, right? And wondering what do you see in terms of like the challenges facing the mechanistic part? I think as like self-consistency and hallucinations, stuff like that. Some of you touched upon that. But we also have the challenge of data like copyright. That is kind of what is happening outside of the visualization use case. Where do we stand on that? Like, how do we tackle the copyright? How do we tackle self-consistency?
No, that's a really good question. And that is something we have been tackling in the Tableau community. So like Tableau Public, yes, it's a free platform. People put a lot of creative vizzes out there. And you know, we have been trying to explore ways in which we can bring that content as forms of inspiration to folks who want to get started in Tableau. And it's not easy. I mean, as rightfully expected, you know, these community members would like to be acknowledged and compensated, especially when you're building tools that we're charging customers for, right? I mean, it's the same thing that we've seen with movies, you know, AI taking like voices from actors. And I think it's still a very unsolved problem. And I think we need to do this responsibly, because if we are, I mean, even the stuff that we get just by playing with ChatGPT, it's all human generated content that we are benefiting from in different ways. And yeah, I don't have an answer to it, but I think it's a very important issue. Pau is smiling, so I feel like he has the answer to it.
No, I don't. The thing is that I don't. The good thing is that I don't work in a company that gives any kind of or deliver any kind of products or services, which I somehow feel a bit more exempt than you on that sense. Still, this is a struggle in the studio because we use, of course, so many models which are actually black boxes, as we know, and we don't know what they have used to be trained. Well, some parts we know. So far, our way of doing it is actually fine-tuning it with our own resources, with our own information, with proprietary data. So the weight of the value of the model somehow is reweighted towards the value that we have brought to the table. But I guess like this is a much complex part or a much complex dilemma for the big companies delivering products.
I mean, small language models is kind of where we're going for things like that, where we can have more control over the input and use that. So that's something we've been actively exploring.
Another question? Yeah.
Hi, I'm Khoury. I'm a faculty at Khoury and Kennedy. So I'm curious that, you talked about how AI has improved accessibility of some data visualization aspect, and I agree with that. And just as a context, my background is accessible computing, so I work with people who have disabilities, and I know that there has been within academics, there is more and more increased work looking into accessible data visualization and accessibility of AI. I'm curious to learn a bit more about any initiatives or any effort around accessibility of database from an industry perspective, like, is Tableau or other companies are thinking about data visualization, accessibility, or even when we think about, like, incorporating ChatGPT or another tool into the pipeline, as that could still be inaccessible for people with different kinds of disabilities. So I'm just curious, is industry thinking about these challenges at all?
Victor, do you want to go first? I don't want to hog the questions.
So one of the experiments in so first of all, I haven't spent too much time working on this space, so my responses here may be limited, so I have to couch with that. But one of the benefits of representing visualization as code is that again, perhaps you could lean on a generative AI model to generate like captions or explanations or some sort of like descriptions of the chart and what it's doing. And I think in LiDAR, there's a module called something called the visualization explainer. And so, for example, if you've used the LiDAR UI, there's a button that says, let's say at some point you sort of either express your intent or you use one of the automatically generated intents and you get a chart that looks like this. So this is a matplotlib chart. And this is the Python code that generates that chart. So there's a button there that says like explain this chart. And essentially what happens is that like it first comes up with a description of the physical properties of the chart. Say it's a box plot that shows the distribution of this, that the x-axis represents this and the y-axis represents that. And then it will also try to explain what each part of the code does. And so it breaks the code into several snippets and explains exactly what each of these things does. Now, all of this is still just research demonstration wise, but I feel there's an opportunity to use a similar approach and maybe even a multimodal approach. So in this case, we're explaining the visualization just based on code, which is limited because things like overplotting, overlapping axis may not be exactly obvious here. So maybe the right way to do this is to have both representation and visualization as text and code, and then get LLMs, the multimodal, to generate, let's say, accessibility descriptions of the content of this chart, and then to fold that into a product feature. I think these are my general thoughts on the area, and I think there's a lot of great opportunity there. But I'm happy to hear what others sort of think about this.
And there's ongoing research in this space. There's quite a lot.
Right. I think from our end, what I've been personally involved in is, I don't know if I can share, but let me just share this really quickly. So we have seen that, a lot of our Tableau authors create texts and descriptions that can be fed into like screen readers, but it's a very tedious job right now to be able to do this, at least with tools like Tableau. It's there's a lot of friction, and you have and the onus is on the author to do this. But we've seen a lot of precedents with, you know, creating text for describing charts, instruction on how to navigate. And so we've been doing a lot of work in the space of text and charts in particular. I mean, I know that's only one of many things for making charts more accessible. Some recent work that is currently under review that is looking at ways to auto-generate this and provide alt text that can be used in screen readers and so forth. Also, just automatic ways of taking charts that are not colorblind friendly into like more colorblind friendly palettes, for instance.
Yeah, thank you so much.
Any other questions?
I was kind of curious, you know, playing off the idea of democratizing charts. You talked a lot about training LLMs to do a better job and be more accurate. Is there some way, what are your thoughts about creating a way that LLMs can train us to ask better questions, give better prompts, explore more sort of things along the lines of what Pau was seeing in the Bible, for example?
I think for me, this is like the basis of adversarial thinking, which is, I think there is this beautiful question, beautiful quote from James Carr, who says the value of a well-used tool lies not only in what it produces for us, but in what it produces within us, right? So I think sometimes when we use all these tools, we are somehow delegating part of our work to the technology that we are using. And by doing that, we are detaching ourselves to part of the knowledge or the insights that we can take from following that process. And I think certain tools need to be designed not to make us more lazy and just do the things quicker, but to actually go deeper into the topics that we are trying to explore. So I think, again, going back to what I said before, adversarial thinking is something that could be entangled within any kind of tool to have like a better understanding, a more critical perspective about anything that you are doing, a reformulation of maybe like whenever you prompt something or when you are trying to visualize something, there are 3 questions that arise. Is this that somehow help you reframe what you are trying to say? But at the same time, this has certain, I don't know, like downturns, which are that artificial intelligence can like very easily misinterpret what you are trying to do, right? And can somehow sometimes mislead you into places that have no insights or have no interesting information. So I think it's a kind of a dance between these systems and your own insights, I think.
One thing that I'll just share here is this is just one of many places for using LLMs to nudge people in places where they haven't gone with the data set. So we've been looking at systems that suggest questions. It's like, have you, and these questions are not just generated as a brute force. We look at kind of data interestingness, are these things correlated? Is there some interesting pattern? Because what we found is even with tools that are like these chat interfaces with data, people don't know where to start. There's like that blank slate problem. So I think fundamentally, looking at AI as an enabler for nudging people in different ways that they may not have gone, or even just getting them out of that blank slate paralysis, right? Both with writing, chart creation, and then providing scaffolds so that they can kind of go out and explore the way they want to is something that we have found to be promising.
Okay, I think we should wrap it up. I want to, first of all, thank our panelists. Thanks so much. Really have learned a lot. I have a lot of other questions that I can ask for the next 2 hours. And I also want to thank all the participants for being here. Thanks so much.
Thank you. Just an announcement, and yeah, just confirm the pattern. And so the next conversation of this Center for Design will be again involving AI, not just AI, also XR, some emerging technologies, and how we can use design to create better experiences using those technologies. So will be moderated by Casper Hartwelde, that is especially in charge of everything game design here, but I'm sure will be even broader than that. So yet another conversation about AI, and hope to see you again next month for this other meeting. Thank you very much. Thank you all for joining online.
Let's stay for there's some food.
Pizza if you want.
There's some food, so please stay. There's a lot of food.
Thank you very much.
Pau, Victor, thanks so much. That's been amazing.
Thank you very much.
Thank you. Thank you for inviting.
Thank you, everyone.
Bye, guys. Thank you.
Bye.